Okay, so find the limit. It's a polynomial divided by a polynomial. It has an obvious point of discontinuity at x equals 1, and we're trying to find the limit as x approaches 1. Right? So that's the kind of interesting problem that we have to be able to solve here. Right? If I look at the graph on the calculator, load file, I think that was 4. It actually looks like a parabola. Obviously, when you divide out that x minus 1, it's leaving a quadratic because it looks like a parabola. But it should be undefined at x equals 1. Well, look in the table of values. Sure enough, at x equals 1, there's an error. Right? So again, we could try to estimate the limit by taking the average of the number that goes before and after x equals 1. Right? In this case, it would be 1 plus 5 over 2, which is 3. That's a first estimate. Okay. Let's try to make the resolution a little better. Instead of using an increment of 1, let's take an increment of 0.1 and see what we get. So go back to the table set. Second table set, 1. So let me make this 0.8 as a starting point and 0.1 as the increment. And let's look at the table of values. Okay. Okay, if I look at the number that goes before and after the point of discontinuity, that would give me 1.81 plus 2.21 over 2, which is, what, 4.02 divided by 2, 2.01? All right. Is that right? I mean, how do you know? You don't know. You just try to make the best estimate that you can. Okay, let's try to do it one more time. Go back to the calculator. Let's make the increment will be this time 0.98. And I'll make it 0.01 and see what that does to the table of values. Okay, if I look at the number before, right, and the number after, here's our numbers. 1.9801 plus 2.0201 divided by 2. And that's what? Is that like 2.001? Close to that? What does it look like the limit of this thing is going to be? It looks like it's probably going to be 2. So we're going to say the limit is 2.